Smokeless Chimney presents.
Welcome to the Fire Time Podcast, where it's never hot enough, slow is fast, and the way to win is to make it so stupidly easy to buy from you that there's no excuse not to. I'm your host, Tim Reed. And once again, I'm so excited to be here today. Welcome to the Fire Time Podcast. Now, as we get into today's episode, this is a conversation that I found super interesting. So laying my cards on the table, when it comes to burning wood, I would say that I know more than the average person, but I am not an authority when it comes to understanding the exact science of testing methods, how the federal reference method works, what the EPA is doing. I understand at a high level, but I rely on experts for the details. And today's episode is with one of those experts. What I found personally for me when it comes to being an authority on the science of wood burning, my two go-to people that I'm always going to call first are going to be Noel Putaansuu and Chris Neufeld. And today we get to chat with Noel. Now, Noel is a contributor for the Firetime magazine. I first connected with him about a year and a half ago at the very beginning of the pandemic. And Noel is somebody that I have seen really pushing the boundaries when it comes to innovation in our industry. And so today we have a conversation that is really based on an article that he wrote for the Firetime magazine that's called "The Wood Stove Certification Process Does Not Match Reality." And first off, I loved that title. It was so punchy. It cut straight to the chase, and it's absolutely correct. So I wanted to have Noel on to talk about, what should we be doing in regards to the way that we test wood stoves. He has some thoughts, and honestly, in this conversation, I didn't walk away with a lot of conclusions. I walked away with just a lot of ideas. And when I think about things over the last few years, I think our industry has been in such a push for making stoves have less grams per hour of emissions that we have, I'm not going to say forgotten about, but we have set aside the performance of the stove and other types of innovation. Now, this is not true for every company, but I would say for many companies it is true. Grant Falco talked, this is, a couple years ago when everybody's saying, oh, we burn so clean, and he would ask, how does it perform? All of a sudden you started putting catalysts in your wood stoves and you've never done that before. How does that perform for the average customer? You've made these wholesale changes where now the stove, is allowing so much air to come in and it's uncontrolled. Is that going to, affect the user's experience? All that to say, what I think that Noel has done is that he is really pushing the boundaries of, could we automate wood stoves to actually start to control emissions? And he believes that there's a factor in the test method that's not really being taken into account that could standardize the results of wood burning, whether you're in Oregon, where I live, or New York, or Pennsylvania at any type of elevation, and we get into that. Because the heart of the problem is wood's an inconsistent fuel, right? So if we're going to test a wood stove where I live, it's going to be different than a stove in a different part of the country that burns a different kind of wood with different density. And because wood stoves are draft-based appliances, depending on the height of our chimney and the diameter of it, these are all factors that affect how things burn. And what we talk about is that the current test standard was never intended to test in the real world how clean a stove burns. It was intended for something different. So all that to say, I want you just to hear this conversation. My mind is still spinning from it. And even as I'm recording this, there's ideas that are going through my head about what innovation could look like in the future. So I hope you enjoy this conversation with Noel. Joining me from Olympia, Washington is the president of Smokeless Chimney. I'm joined today by Noel Putaansuu. Noel, how you doing?
I'm doing well. Thanks for inviting me.
Cool. Well, I'm really glad to have you here today. I've appreciated just reading all of your columns for the Firetime magazine throughout the year. And you're an authority on all things wood burning. And the stuff that you've written about, what's been really cool is I've talked about it with Matt Bradley. You write about very technical things, and sometimes that can come across as dry or over people's heads, but what you've done a really good job of is taking complex topics and breaking them down in the simplest form possible and also making it engaging at the same time. So that's been really cool, man. We've appreciated everything that you've done.
Well, thank you.
So the first thing I want to do, I want to talk about an article that you wrote a couple months ago that really, really spurred my curiosity, and we'll get there in just one second. But before that, I'd love to hear a little bit about your background of working with the science of wood burning and how you started to get involved with our industry.
Yes. Well, I started in the early 80s working for a forest products company where I had to gear up their hood systems for doing fire testing. We would do fire testing on several things. And one of the things was an opacity monitoring system for the fire tests. And in that day, that equipment was rather expensive and sensitive. And I watched as it got a lot less expensive over the years. But I see a lot of failures in systems as a fire investigator over the years. And one of the things is uncontrolled wood stoves. They just sometimes can cause fires. And I thought, well, I can do something about that. I know how to measure it. And if I know how to measure something, I can do something about it. And that's the first step in fixing something, is if you can measure how it's gone wrong, you can take steps to prevent that.
Noel, that is so good. I'm literally writing this down as we talk, that if I know how to measure something, I can do something about it.
That is key.
So as we jump into this, you have had this experience as a fire investigator. You have now jumped in as an entrepreneur to start building products to help people burn cleaner. I want to talk about what went into this article. So the wood stove certification process does not match reality is the title of it. And as soon as I saw that title come through, I said, yes, this article needs to be written. And I just love the fact that it pulls no punches. And I'd like to just tee you up right now and let's talk about this. What went into your mind as you put together this article that the wood stove certification process does not match reality?
Well, one of the things is having worked in fire test laboratories, I know that what goes on in the lab is highly refined, highly watched, and I know what the laws are outside. So I see people getting fined with wood stoves, running their wood stove in certain areas, and I thought, yeah, they can take a certified wood stove and put it in a house and it can be out of compliance with the law on the first burn. What's wrong in this picture, and why don't people see this? And so I think that's why I needed to write an article that said they're doing very discreet things in these labs and they're watched very carefully, but they're not recording the one item that they need to. And a certified stove doesn't match one that meets the law. And so they're two separate things.
Can you talk about that just a little bit? So this is really important. I think a lot of folks don't think about this as often as they should. So a wood stove that's tested in a laboratory, just like there's no ifs, ands, or buts about it, it doesn't match reality, and it's actually not even intended to, right? Like why would that be the case that someone would make a test that way?
The test method in the lab uses a mass method. They use a complicated method to pull gases out, and then they weigh filters for the mass. The law states in Washington state, you can't produce more than 20% opacity for 6 consecutive minutes of any hour. And they use what's called the Ringelstad method, which is a couple pieces of paper, ink blotches on a paper. It was a method developed by the Bureau of Mines in the 1890s. And that is the current standard for the smoke police. They can only work from the public right of way. So if it's on a road, they have to stand between the white lines of the road, and then they have to hold the ink blotches up to your smoke coming out of your chimney. And the method is about 10%, plus or minus 10%.
Interesting.
At 20% opacity, plus or minus 10%, doesn't give a lot of margin.
So if in a lab, if I've got a set criteria to test stove A against stove B to just get some kind of a baseline of like, do these burn relatively clean or do they not? Is stove A cleaner than stove B? that is going to change in the real world based on my elevation, the height of my chimney flue, the type of wood that I burn. Is opacity a way to get us closer to real world performance?
I think so. One is easy to make opacity. Opacity is simply a light beam and a few electronics to figure out how much of the light is making through. And the systems I have are good to at least 1%. And that's a lot better than the Ringelstad method.
Yeah. And I guess as I'm thinking about this, I'm fascinated by this talk of opacity. I first heard of it a couple years ago at the trade show where a manufacturer was starting to mess around with the idea of opacity inside of their stoves. And I remember at the time they were talking about how this is actually used in like all kinds of testing that right? I mean, isn't this used in like the auto industry and plenty of other fields as well?
Yeah, diesel trucks are limited in opacity, and so they have an opacity system that looks like a chimney system. And industry, so if you have like a dust chimney that has dust coming out of it, you might be required to put an opacity system to monitor the opacity of your emissions. So they're used in industry. They've been used for years in industry. They're used in diesel trucks for emissions. And I think we are headed in the direction of using them on wood stoves.
It's very interesting that, if my neighbor's house is, making my kids cough, they're going to come out and do an opacity test. And that's incredible that that's actually not what's being tested in the labs. Is that correct?
That is my understanding. I do believe that the labs are measuring opacity, but it's not required to be reported.
Well, that's where I want to go next. And I'd love to just tee you up and kind of hear your thought on this. So if we know right now the EPA test method is under fire, and there's questions about kind of what's going to emerge from that. But the real question seems to be, how do we get a test method that works in Albany, New York, and Portland, Oregon, and Denver, Colorado? Regardless of my elevation, my chimney height, how do we know how clean these products are going to burn? If you were in control of the industry or the government, and you could institute either a test method or equipment in particular, how do you feel like we could start to get accurate results to compare these different geographies?
I think the test method, they don't need to change anything in the lab. I think if they include opacity and then some monitoring of the opacity of an installed chimney of the same to see how it compares to what was recorded in the lab. Yes, there's going to be differences in moisture content of the wood, the type of wood burned, and the amount of air that the wood stove is getting. However, we're going to be able to compare apples to apples at that point.
I'm just thinking about this. I mean, and I don't know. I mean, you see stoves that have like a barometric damper to open and close based on heat output. Like, would it be possible to make a non-electronic device that would open and close based on opacity?
It would be possible. However, it's inexpensive to do it with electronics. And because an opacity system is a light-based and the sensors are electronic, and it's electronic at its core, I think you have to go to the lowest common denominator and say,
sure,
it's an electronic system.
Okay.
Because at least when I design the systems, the opacity measurement is outside the house where it releases to the environment, right 1 inch before it releases to the environment.
Oh, interesting.
So I communicate the data via Bluetooth or Wi-Fi down to a controller I put on the wood stove. And so I think it has to be pretty much an electronic system. Also, if you want to control something, hook it up to your home automation system.
Sure.
Or let's say you're out to dinner and you take a peek at how your wood stove's doing. You want, it's an electronic system.
Yeah.
And the electronics are inexpensive right now.
It's amazing. We'll get back to our conversation with Noel in just 1 second. Hey, if you've been listening to this podcast for a while, you have heard me talk about the Firetime magazine. But if you've not downloaded the Firetime magazine app, you got to change that. So when we set out to create this magazine, we tried to ask the question, how can we take the momentum of the podcast and share its reach with more people, but also include more voices? And that is exactly where the Firetime magazine came from. So we have a contributor team of about 15 people from all across the country that are producing unbelievable content month in and month out. Like I read it. I mean, as a consumer, I read it thinking like, there's never been anything like this produced in our industry. It's unbelievable. And it's because there's a multitude of voices. Now, we've had the magazine in a digital format for months, and you can find that online. But recently, we have launched audio articles, and these are available through the Firetime magazine app, and they're intended for people that are on the go, right? If you're in a service truck, if you're on the go, or if you're waiting in the airport and can't pull out your tablet or your phone to read the Firetime magazine in an easy way, we wanted to provide a simple way to deliver you that content. So, to get your hands on the latest issue of the Firetime magazine and listen to the audio articles, you need to download the Firetime magazine app by going to itsfiretime.com/app. That's itsfiretime.com/app. One of the things that has come about as we've seen this push towards NSPS Step 1 and Step 2 over the last 10 years is I feel like there's been a mad dash to quote unquote make stoves clean. And clean again means that it meets the criteria set forth by the EPA. And I'm fine with that. I want good air quality for everybody. But I think what has been forgotten is frankly innovation and also performance. So just because a stove burns clean doesn't mean that it performs well. You know, because the tighter that you choke down a stove, the harder it's going to be to draft, and there's pros and cons that come with all of that. But what I'm wondering is, I mean, I haven't seen much innovation when it comes to wood burning from many companies over the last 10 years. You know, I mean, a couple of years ago at the trade show, seeing the opacity monitoring was pretty incredible. But I feel like what you're talking about is serious innovation that helps the performance of the stove and how clean it burns. And I'm wondering, like, are more people thinking on this wavelength of pushing forward when it comes to innovation, or do you kind of feel like you're alone in this?
I pretty much feel like I'm alone. And that's partly because corporations don't communicate well with outsiders.
Yeah.
I think of it like a automobile in, I had a Model T and I had an FJ40. They're carbureted vehicles. And an automobile, you want 14.7 units of air to each unit of fuel mixture. And the computer controlled systems like a Prius or an electronic fuel injection system is always changing things to try to match that stoichiometric mixture of 14.7 to 1. And it's measuring and making adjustments multiple times a second. The best wood stove operator makes adjustments to their wood stove about once an hour. And it's fires are dynamic reactions or dynamic chemical reactions. They need constant adjustments to make them burn better. The more often you make a measurement and adjustment, usually the better performance you'll get, both with safety, efficiency, and ends up being lower emissions as well.
It's fascinating. And I think that like the push and pull that I'm just thinking about is like, on one hand, a lot of people, historically have bought wood stoves because they want something easy. They want something that's reliable in a power outage. They just want old faithful. They can throw wood in and they can get warm. And what you're talking about is kind of a step in a different direction. Do you get, or do you like, what do you do when you come across people that say it's too much work, it's too much hassle, it's not worth it?
Well, I have 2 teenage boys and a wife. Love them. They cannot put wood on the stove at the right time. I don't know why. I've talked to them about that. And so part of the system I'm making is it tells the user, now's a good time to put some wood on the fire. Now's a good time. If the wood stove gets too cool, if the temperature of the wood stove in my situation gets below 250 F, I know that if you put new fuel on, it's going to smoke more than if you put you refuel it above 250 F. We're trying not to have as much smoldering combustion and more flaming combustion. And people like flames. Flames put out light, they put out more heat, and they put out less smoke. So we all like flames.
I love that. I mean, and it's funny to think that, you're the only one that can put the wood on. And I've just never even thought about like an optimum time below 250 or above 250 in your case. And I think that, I don't know, I've just always taken for granted like, oh, the stove looks low, so I'll throw some wood on. But if we actually are after better performance and burning as clean as we can, it's interesting that it's just interesting that I'm just now 15, 16 years into the industry hearing this conversation about there's actually a way to monitor this. And I think what it makes me excited about is existing stoves that are out there. So we've talked about this a little bit offline. I've been a part of wood stove changeouts locally where I live, and they've been amazing initiatives to clean up air quality because, right, you've got all these dirty stoves that are 400-pound boat anchors that never break, and they're pumping out, tons of particulates into the atmosphere. And the answer has always been throw them away, get rid of them. But there's a couple problems. One, you're throwing away like 400 pounds of steel that, you can recycle it, but in some ways it kind of seems like a waste. Number two, it's really, really heavy and cumbersome to get out. And number three, to replace a new stove and chimney system, you're pushing easily $5,000. Easily. And that's a monstrous expense. So you believe, I don't think I'm putting words in your mouth, like you believe that older stoves can be retrofitted to burn clean, right?
Right. I believe that it's going to have to be done by chimney shops, your maintenance person that does the chimney sweep.
So what kind of equipment would be used to retrofit an old stove? Like if I've got like an old self-made welded box in my garage.
I use combustion air fans and combustion air fan controllers, and for me it's really easy to figure out how much air a wood stove would need, and I tune the system for the maximum power of the wood stove. So if it's a maximum power of 20 kilowatts, I give it just a little more air than a 20 kilowatt fire would need.
And you think, if I'm understanding you right, you think that a local chimney sweep or hearth retailer could go out and calibrate this for a customer?
Oh yeah. One, they could check the gaskets to make sure the wood stove is sealed. And then it's a matter of installing an adapter plate and some plenum tubes. And it would be no different than connecting up a hairdryer to a person. And then the chimney system would be mounted like a chimney cap. So it would be a little more complicated, but in a nutshell, it's the same. You're installing parts, they all attach with magnets, and so you can pull them off. We're not permanently modifying anything. They're just add-on parts. And there are so many automotive stores to buy parts for your car. We need stores that sell wood stove parts to add to our wood stoves.
It's fascinating. My mind is just blown as I'm thinking about this. What would happen with like EPA compliance and testing? Do you think that that's anything that could ever get through to where a stove with these aftermarket parts could be quote unquote certified?
Well, here's how I think it would work. We'd use opacity monitors to compare an old stove to a new stove, and we can record all the data.
Yeah.
So the data can be beamed to the cloud if the customer allows it, and we can compare one stove to another and length of time burn and a lot of other. We can record quite a bit of stuff, and then we can math model it.
Yeah, that's fascinating. So if I'm hearing you right, so let's just say on an EPA test in a lab for a wood stove, and let's say that stove burns 1.9 grams per hour averaged out between all the different tests that they do, there's going to be a corresponding opacity to that. And if that is documented, then as long as that opacity is met or your opacity is less in the real world, you could compare data and prove that a stove is like an old stove with this new equipment is burning properly? Is that
We can tell, yes. And there are certain things you can do. For example, the temperature of the stove to its opacity. Like I say, mine visibly smokes less at between 250 and 450 than it does when it's running at 150F. If it's running at 150F, it puts out quite a bit of particulate. But once it gets to 250, cleans up quite a bit, and it's clean, at least visibly, up to 450.
And I got to ask this. I mean, in like these aftermarket systems that you're a part of, is there like a catalyst or anything like that inside to be burning up particulates?
No, we're trying to put in the correct amount of air for the ever-changing dynamic chemical reaction that's going in the stove. I think of a wood stove as an internal combustion engine, like a car.
Crazy. So you think that an old stove that has no secondary combustion technology or catalytic technology, with the proper airflows and opacity monitoring, that you could get that to burn underneath the EPA standard today?
We could get it to burn under the 20% opacity figure that the state requires.
Okay.
I don't know if we could match the EPA because of the test method is completely different. We're not going to take the old stove out and take it to the lab and run it again. The only way you can compare stoves one to another is by opacity. So we use the opacity as the measuring stick, and we can compare one stove to another.
Man, my mind is going in so many different directions. As we round out here, I wanted to ask you your take on the NESCOM situation. So the NESCOM report came out, this air advocacy group from the Northeast, basically accusing a lot of different parties, but essentially the EPA and different fireplace manufacturers of either consciously or unconsciously omitting data from their test reports. That's the best way that I can kind of simply explain it. And there's a lot of controversy about this. I'd love your take.
Well, test labs do what test labs do, and manufacturers do what manufacturers do. I'm not sure that the test labs do anything wrong, and I'm not sure manufacturers do anything wrong. I think they should choose a method that is reproducible, that when you take the wood stove out of the lab and use it in the field, and you can measure it, opacity is that method. I don't see how you can take the EPA test method and use it out in the field.
Sure, you can't.
But I think the test labs all did a great job. They did the test according to the standard. I just don't think that doing a test in the laboratory represents using it in the field. And anytime a third party looks at the data, if they can't get their hands on all the data, they think it's foul. Mm. And test labs aren't really supposed to give out their data, so they have to go somewhere else to get it. So it's an accounting problem. And manufacturers can't provide their data for some reason. It's not a big deal. I think it points to we need a better method.
Yeah. Well, Noel, this has been awesome, man. My mind is spinning. I love this idea of a way to retrofit older stoves to burn clean. And I know that you're involved in this day to day. If people want to get in touch with you, like you have products to do this, how could somebody get in touch with you?
My website is smokelesschimney.com.
Cool. And I know that they can read about your content in the Firetime magazine. It's been awesome having you on, Noel. Thanks for being here.
My pleasure.
Well, I hope you enjoyed that conversation with Noel Putaansuu. Like I said, my mind is racing, and I'm asking all these questions. So I have always thought about clean burning in terms of grams per hour. And him talking about opacity is just mind-blowing. Like, I do remember a few years ago at the trade show, there was a manufacturer that was displaying a stove that had a laser beam going through it, and it had some automation tools to try and make the stove, perform better. And I remember talking to the president of the company. He was saying, Tim, like, we could put a car tire in this stove and it would burn it as cleanly as possible. And the idea, I thought was terrific. And I'll say over the last few years, I haven't seen a ton of innovation from large manufacturers when it comes to the way that we burn wood. There are some exceptions to that. There's two manufacturers in particular I'm thinking of that have had some really innovative ideas, but not at large. And Noel's idea of opacity, I'm sitting here thinking like, so okay, does that mean that if a stove can pass an opacity test, like, does that mean that it burns under X amount of grams per hour? And even, as we were talking offline, the idea of like in the state where I live, that when you go to sell a home, a stove that's not EPA certified has to be removed. And so what's interesting about that is that there's a lot of questions in how you apply that law, because when you apply that law, the question is it current EPA certification? Is it EPA certification when the stove was put in? And the answer to that question has been nebulous. And so what Noel suggested as we talked offline would be the idea that in states like mine, if you could lobby to say, yes, if the stove is not EPA certified, it has to be removed at the time of sale, but there is an exception for stoves that meet an opacity standard of XYZ. And that would be a way to, not even have to mess with EPA testing necessarily, that new stoves being put out still have to, meet some kind of an EPA standard. But at the local level, you don't have to remove stoves that are proved to perform well. So, like I said, my head is kind of spinning, and I don't know what the best answer is, but what I love is the fact that Noel is asking questions in a really just insightful and different way. If you look at the products that he has, they're pretty unbelievable, and I think that these are the conversations that we need to have when we talk about pushing the envelope forward in wood burning. So I hope you got value out of that conversation and it made you think just like it did for me. Now, if this podcast has been a blessing for you and you want to support it financially, you can do that by going to the website patreon.com/itsfiretime. That's patreon.com/itsfiretime. My hope for you as you go out this week, in the same way that we're talking about innovation in wood burning, I would just be thinking about like, what's a way that I could be innovating, Whether you're a manufacturer and this conversation inspires you to start thinking about, opacity in your testing, or just thinking about the problem in a different way. If you're a dealer or a distributor or sales rep, what is a problem that, a lot of people think there's no answer to that you might be able to do something about by thinking differently? I think that at the heart of this conversation, that's what I appreciate, is this idea about thinking differently. And, going back to the very beginning, what Noel said about, if I know how to measure it, I can do something about it. And I think there's a lot of truth to that. So I hope you have an amazing rest of the week. As always, we're going to be back with more very soon. Thank you for listening to the Fire Time Podcast. To learn more, visit the website itsfiretime.com. Music from this episode was written and recorded by In Bloom out of Portland, Oregon. We thank you for listening to the Fire Time Podcast, where it's never hot enough, slow is fast, and the way to win is to make it so stupidly easy to buy from you that there's no excuse not to. We'll see you next time.